Hello, welcome back. This is lesson 6. Today is Monday, I think. So happy Monday, if it is Monday. If it is another day, happy whatever day that is. So today we're going to talk about, continue the conversation on voltaic cells. On what I'm guessing was Friday, whatever the last lesson was, we kind of introduced electrochemical cells. And we talked about how there were two types of electrochemical cells, voltaic cells and electrolytic cells. So the plan for today and tomorrow is to practice with voltaic cells in more detail. Wednesday, we will go over electrolytic cells. Thursday, we'll kind of practice mixing the two together with some Regents questions. And Friday, you'll kind of see this in action with another case study. So as we're working on this, it would be helpful if you watch this video to go over the first question and then pause it to go over the other three, try the other three on your own, and then watch it to review what we've talked about. It doesn't look like anything is due tonight. Just make sure that you are following the calendar on the website, whatever schedule is posted, and whatever updates your teacher may update you with. So let's get started. Today we're going to label pictures like there's no tomorrow because it's awesome. So starting with this, we are going to, so you should probably be looking at the sheet that says voltaic cell practice. That looks like this. So for each cell, we're going to label anode and cathode, figure out which way the electrons are flowing, and then write the reduction reaction, oxidation half reaction, and then the combined balance redox reaction. So kind of connecting everything we've done so far. Okay, so first step is to find out which is the anode and which is the cathode. So you're going to need table J for that. And remember, the thing that is higher up is going to be the anode. So in this case, cobalt is higher up. So that makes this the anode, and nickel will be the cathode. Now, check that off. Direction and region of electron flow. Electrons always flow from the anode to the cathode. So electron flow. Right, E minus anode to cathode. That is always the direction it moves. If it helps you to think of the alphabet, A to C, that works. So then we talked about, we know reduction happens at the cathode, oxidation happens at the anode. Yesterday, or Friday, we had mentioned Leo says GER every day since we started this unit. We talked about red cat, which is how you can remember reduction happens at the cathode, and N-ox is how you can remember oxidation happens at the anode. Okay. So if we're going to write the reduction half reaction, we're talking about nickel. So that's over here. So remember, reduction is when you are reduction is when you're gaining electrons. So you have nickel plus 2 electrons gives you Ni0. So when we're writing half reactions for this, the metal, the cathode, whatever electrode, so electrode is the overall term for cathode and anode. Whatever the electrode is, that is your oxidation state of 0. And then in this liquid, you have the free-flowing ions. So you have the nickel plus 2 ion, and you have nickel by itself. So then that kind of leaves you where we were the other day with the half reactions. Again, you have to add that 2 electrons to make sure you have an equal charge on both sides. For oxidation, we're talking about cobalt. We have cobalt 0 and cobalt plus 3. Remember, for oxidation, you are losing electrons. So electrons will always be on the product side for oxidation. And just a rule of thumb for all of it, you're always adding electrons to the more positive side. So your oxidation reaction looks like plus 3, like that. Now, one of the things we talked about is balancing them. Now we have 2 electrons and 3 electrons, so that can't work. We have to lose and gain the same amount of electrons on both sides. So we have to figure out how we can get both reactions to have the same number of electrons. So what you can do is multiply the entire reduction reaction by 3, the entire oxidation reaction by 2. Okay, so I'm running out of room. I'm not going to show every single step of this. If the balancing part doesn't make sense, go back to the 2-half reaction lessons that go over this. So when you do this, you'll have an equal number of electrons on both sides. You can kind of forget that. So your combined redox reaction will look like 2Ni plus 2 plus 3 cobalt 0 gives you 2 nickel 0 plus 3 cobalt plus 3. So with this, you have 2 nickels on both sides, 3 cobalts on both sides. That's balanced. You have a total of a positive 4 charge on the left and a positive 4 charge. Wait, this is a 3. This is a 2. I messed up the enter key. I will fix that. So, hold on. You're multiplying it this by 3 and this by 2. Means you have 2, 3, and 2. Okay. That will be updated on the key. So if you saw the key before this, then oops. Okay. That is it. Moving forward with the next one. We want to, again, first step is to figure out which is the anode, which is the cathode. So the higher up on table J means you're oxidized, which means you are the anode. So zinc is the anode. That means copper is the cathode. Electrons always flow anode to cathode. So if it helps you write anode to cathode a bunch of times, anode to cathode, you can do that. Okay, so we had talked about how reduction happens at the cathode and oxidation happens at the anode. We know Leo says grr, red cat, and ox, so that will help with this. Okay, with the reduction reaction, remember you're gaining electrons, so the electrons will always be a reactant, and it comes out looking like this. Again, using the +2 ion in the water and then the 0 oxidation state of the electrode, like that. And your oxidation reaction looks like that. So it's important to remember reduction electrons are always the reactant, oxidation electrons are always a product. And again, you want to make sure you have balance of charges, so you have +2 and 2 electrons. That makes sense. +2, 2 electrons. So next step is to combine these, and we have 2 electrons being gained, 2 electrons being lost, so we don't need to do any more balancing. It's done. We can kind of ignore those. And then our combined redox reaction would be Cu +2 plus zinc by itself gives you that. And that is it. Going to the next one. Now we have lead and copper. So lead is higher up and is the anode. Copper is lower and is the cathode. So here's a good place to point out that the anode can be on the left side or the right side. It doesn't matter. So that's why you have to check table J if it asks you to figure out which is which. So knowing that, we know that electrons flow anode to cathode. So now it's flowing towards the right. This is electron flow. We know oxidation happens at the anode. We know reduction happens at the cathode. So if we're going to write the half reaction for, let's do reduction first, keep it consistent. It should look like Cu2 plus 2 electrons gives you that. Your oxidation reaction should be Pb0, Pb plus 2 electrons. So again, we have 2 being gained, 2 being lost, so we don't need to do any more balancing. We are good to go. So your final redox reaction will be, again, you can kind of ignore those if they're the same. All of your reactants, which is copper 2 plus and lead 0, and then all of your products, your copper 0 and your lead 2 plus, and that is it. Now, the very last one for today is this one. And if we look at table J, we'll see that aluminum is higher up, which makes it the anode. Lead is lower in this case, which makes it the cathode. And we know that electrons always flow anode to cathode. And we know that reduction happens at the cathode, and we know oxidation happens at the anode. And so now adding or writing these half reactions is something that we've done a bunch of times now. So reduction looks like Pb plus 2 electrons to give you Pb0. Oxidation looks like Al0 gives you Al plus 3 and 3 electrons. So here we haven't balanced in a while. Don't want you to forget how to do it. We have 2 being gained and 3 being lost. That is not okay. So we need to take that extra step and balance it, and you have to think about what number 2 and 3 have in common, and the answer is 6. So in order to get this side, lost my headphone. In order to get the reduction reaction to have 6 electrons, you multiply everything by 3. In order to get the oxidation reaction to get to lose 6 electrons, multiply the entire thing by 2. And then you'll have 6 electrons on both sides. You don't need to write them. And then your combined redox reaction would read as 3Pb plus 2 plus 2Al0 gives you 3Pb0 plus 2Al plus 3. That is it. You have 3 leads on both sides, 2 aluminums on both sides, a total of a plus 6 on the left and a plus 6 on the right. So it is important that you double check it, just like I made the mistake on the first question. Just double checking and talking it through in your head definitely helps, because everybody makes mistakes. But that is it. Have a wonderful day.